All right. Good morning, everyone. My name is McCain Vogel. I'm the assistant editor at No-Till Farmer. Thanks for joining us today for the webinar titled Regenerative Tools for Your No-Till Toolbox, Bringing Life to Your Soil, sponsored by Advancing Eco Agriculture. John Kempf, Chief Vision Officer and founder of Advancing Eco Agriculture, will discuss the relationship between soil biology and no-till farm management. Learn about the value of biological inputs and the changes they can bring to your soil. Before he gets started with the presentation, I just have a couple of housekeeping items. On your screen, there's a control panel with a Q&A icon. You can submit questions there anytime during the presentation, and we'll take those at the end of the presentation. And then one more thing, we're recording today's session, so in the event you want to go back and watch it or share it with anyone, that'll become available to you later on. And without further ado, I'll hand it over to John.
Thanks, McCain. Hi, friends. Welcome, everyone. It feels quite good to be back talking about soil biology and agronomy from a regenerative agriculture perspective. I've had some stuff going on in life over the last year plus, has been a bit overfull, and David Miller and the team have done an awesome job of stepping in and helping out, which I'm really grateful for. And I think this event was originally advertised as that David was going to be here, but then he had something come up and was unable to make it, and asked me to fill in for him. And so I'm really happy. It feels good to be back and having these conversations. I always enjoy the interaction with growers and the conversations we have, because it's when we encounter challenging situations and we have to figure out what's going on. That's when we learn new stuff. So the topic for today's discussion is shaped around or framed around biology and how we use biology to deliver nutrition. And it's really interesting. This conversation has really shifted over the last 4 or 5 years. We started having this discussion back in the early, it was 2006 when I first started doing consulting work with Advancing Eco Agriculture. And one of the principles that I came up with back then that we talked about a lot, that I talked about a lot in describing our nutrition management system, is that product applications have to be a win-win, in the sense that they have to promote both soil health and plant performance at the same time. And that's actually relatively uncommon. It is common for most products to produce a strong crop response or produce a strong plant response at the expense of soil biology. And that's really been one of the things that has defined the way our nutrition management approach is different. I still remember one of the highlights of a recent trip I took out to the West Coast with my family. We sat down for lunch with a farm manager who'd been using our products for the last year, who was very much I suppose you could say, a science geek or science nerd. He had his own biological laboratory and was doing all types of experiments. And he came in and sat down for dinner, and he starts getting all excited. He says, "Your products are alive." It's like, you have biology in your products. And he was talking about our liquid nutritional products, that he can bring them into the lab and put them in a petri dish and actually see the biological component and culture out and propagate biology in our materials that are as plant nutrition products. We're not adding microbial inoculants to our liquid manganese and liquid boron and so forth, but biology is able to live and thrive in those products because of the way that they've been designed. So that's been a foundational premise of how we've approached plant nutrition for a long time. And so it's within that context that I want to talk about so over the last, now flash forward to today, in the last several years, there has been rapid growth in understanding the work of Dr. Christine Jones and Dr. James White and David Johnson and many others has become much more widely known. And the idea that we can use biology to provide some of a crop's nutrition is really inspiring and motivating from many perspectives. It reduces our requirement or our dependency on applied inputs, applied fertilizers. but I think there's still a lot of question marks around how do you implement it successfully? How do you know it's going to work? What does the transition process look like? And so those are the pieces that I want to talk about today, because after all, we've been helping farmers navigate this transition now for a decade and a half very successfully. And I want to kick things off by giving you kind of an overview of the big picture, the principles of how biological nutritional delivery systems work. And then we want to get into the nuts and bolts of what does it look like, how do you implement it, and how do you gain confidence that you're not really screwing things up and costing yourself a crop. So with that, and I'm also I'm going to try to leave plenty of questions or plenty of time at the end for Q&A. You can type in any questions you have at any point in the Q&A box. But when I'm as I'm going through the slide deck, when I'm sharing my slides on screen share, those questions don't pop up for me. So I'm just going to try to cruise through the slide deck pretty quickly and leave lots of time for Q&A at the end. So we will kick things off here. So I'd like to begin with this concept, this realization that nutrition delivery should be biological in nature is not new. It's been around for a long time. William Albrecht first described it back in the 40s and 50s with the saying that fertilizers should be available but not soluble. And this is a really interesting quote, given that today, when you read white papers on how plants absorb nutrition or nutrient interactions, or when you read books such as those that are on my shelf, I'll pull one of them off here. This is kind of the classical textbook of plant nutrition, is Mineral Nutrition of Higher Plants. This is the third edition, edited by Petra Marshner. And in each of these textbooks, they're incredible reference materials. But the first chapter or two always describes how plants absorb nutrients as soluble ions from the soil solution, and how those soluble ions are transported through the plant's vascular tissue, and how they're then absorbed by cells. And it's true that plants have the capacity to absorb simple ions from the soil solution. After all, that's how hydroponics works. And if we rely on that pathway to supply nutrients for a growing crop, then that's simply a glorified hydroponic system in our field. Soil should be considered as much more than just a substrate to hold nutrients and water and to hold the plant upright. It's a lot more than that. Well, there has been this background research been going on in plant absorption of microbial nutrition since the 1920s. There hasn't been a lot of energy and time and money and resources invested in this space until more recently. But we're now in a very different space. For the last decade and a half, Dr. James White at Rutgers University and his colleagues, along with Christine Jones and Elaine Ingham and David Johnson and many other pioneers in this space, have described how plants can absorb nutrition from soil biology. And this could be a whole topic in and of itself, but I want to just introduce it. For those of you who are not familiar with it, there's a lot more opportunity, there's a lot more information available now than there was even 5 years ago. The key piece that I want to introduce is Dr. White and colleagues' research and illustration description of what they're calling the rhizophagy cycle. So the rhizophagy cycle is what they're describing is that the root tip, the growing root tip, as it penetrates and moves through the soil profile, is actually quite open and porous and is imbibing or bringing in entire bacterial cells in large amounts. Hundreds or thousands of bacteria are moving into these open root tips. And then as these bacterial populations, these bacterial cells move back through the first couple inches of the growing root, they are exposed to reactive oxygen species such as nitrous oxide and other oxidizers that have the effect of stripping off the cell membrane. So now you have this naked bacterial cell that lacks a cell membrane, and that naked bacterial cell then moves throughout the entire plant vascular tissue, moves up into the leaves, into the seeds, into the fruit, and is absorbed by the plant cells, and the plant cells use the nutrients contained inside these bacterial cells as a form of nutrition. And what is really interesting is that then not all of the bacterial cells are utilized in this way. Some of them, as they move back a couple inches past the growing root tip, they accumulate. There's often a small community that accumulates there, and that small community triggers the formation of root hair. And then these bacterial cells move back out through the root hair back into the soil environment. And it's really interesting. The plant actually nurtures, and it provides the exact sugars and the mucilage and the exact compounds that these naked bacterial cells need to reform their own cell membranes. And so in this process, the plant is also, as these bacteria are moving through the root system and then through the root hair back out into the soil environment, into the rhizosphere, the plant is communicating to them exactly what its nutritional requirements are. It's telling the microbes, hey, I need more zinc, or I need more manganese. And that bacterial population, and those bacterial cells, as they move back into the soil environment, then communicate those signals and that genetic information to the entire rest of the soil microbial community through a number of mechanisms. There's quorum sensing and electrical signaling, biochemical signaling, and also the exchange of genetic information. So there's this rapid signaling that happens throughout the entire soil microbial community, and they recognize that, hey, these plants that we are depending on for a sugar source need more of these nutrients, and when we give them more of these nutrients, they're going to give us even more sugar because they can photosynthesize better. So there's this symbiotic collaborative relationship that's going on between plants and soil bacteria. In the podcast interview that I did with Dr. White almost probably 2 or maybe now 3 years ago, I asked him the question, how much of a plant's nutrition can this rhizophagy cycle process provide? Are we talking about 20% or 80%, or what does it look like? And he was hesitant to give a confident answer because the research hasn't been done largely. But he was willing to speculate that in non-domesticated crops, in other words, in wild plants that are growing out in the forests and meadows and so forth, that upwards of 95% of a plant's nutritional requirements are coming from bacterial cells rather than from simple ions from the soil solution. And this is not a surprise for me because many of us have observed large trees growing out of bare rock surfaces. There's all kinds of images and photos online if you haven't seen any of these, but you can have large trees that are actually relatively rapidly growing. It's not like it took them hundreds of years to reach the robust size they have, although that can be the case in some harsh environments. But here where I live, within 10 miles, we have what we call the Nelson Ledges Park, and we have maple trees that are probably, I've counted some of these stumps, they're 45 to 50 years old and 25 to 30 inches in diameter, growing out of bare rock. There is no soil, and there has never been any soil for those trees' entire life. So how do they get nutrients? It's obviously not from nitrogen and calcium ions in the soil solution because the soil solution doesn't exist for them. So there's this whole combination of microbial synergies with algae and lichens and fungi and bacteria colonizing the rock surface and then providing nutrients to these trees. And this same process can also work in our agricultural soils. I find it interesting. We have demonstrated on a field scale now that this rhizophagy cycle and this process of supplying biological nutrition can deliver, in fact, I'm confident it can deliver 100% of a crop's nutritional requirements. We have worked with organic growers where over a period of multiple years, gaining additional experience, we have soil analysis data that shows that the soil has minimal levels, as in I'm talking less than 5 parts per million of detectable nitrate, detectable ammonium. Like, there is no mineral nitrogen in the soil profile. It is all present in the form of organic nitrogen, or you could say bacterial cells. And yet growers are producing 240, 270 bushel per acre corn crops with non-detectable levels of nitrate and ammonium. It's not that they're not getting nitrogen. They're getting plenty of nitrogen, but just not in those forms. So if you want to dig deeper into this, I can't possibly do this conversation justice in just a few minutes. Look up Dr. James White. There are now a number of YouTube clips. I've interviewed him on the podcast. He's been kind enough to put together an in-depth short course that is available on kindharvest.ag. So it's about 3 hours deep dive at kindharvest.ag. And he's also published a number of peer-reviewed papers on this process that I've referenced in my blog posts as well. I've written about a couple of blog posts about this topic. So there's a lot of information available out there now. The key point, though, is this. Every one of these books, those introductory chapters are now going to have to be rewritten, because there's now an additional pathway, an additional component of plant nutrient absorption that hasn't been considered in our historical agronomic models. And it is the reason, as we understand and learn more about biological nutrient delivery, this was the motivation for the development of the Haney soil analysis. It's the recognition that mainstream chemistry-based soil analysis don't acknowledge the capacity of biology to deliver nutrients. And also the incapacity of dead soils to not deliver nutrients. So plant nutrition must be win-win. I mentioned this at the beginning, whatever plant nutrient products that we apply to our soils need to not just enhance plants, they need to enhance both plants and biology in parallel. And many typically applied nutrients and fertilizers fall short in this regard. And so we need to buffer out the high salt index that they carry and the high levels of electrical conductivity that can oxidize microbial cells. And I'll speak a little bit about that. So these are the 5 major pieces, or 6 major pieces, that I want to speak about in the next 20 minutes or so. First is, how can we transfer nutrition contained in cover crop residue or in historical crop residue into the following crop very efficiently and effectively? How can the value and the necessity of colonizing root systems immediately during germination for this process to work effectively throughout the crop's life cycle? The ability and the need to immediately convert any form of nitrogen that we apply to this organic microbial nitrogen. And then I'll want to walk you through a quick example of what a biology-centric nutritional protocol looks like. And then lastly, I want to speak a bit about some of the tools that you can use to gain confidence that you're not screwing it up and that your crop actually has the nutritional requirements, its nutritional requirements being met. Because what we're talking about is it's a different way of thinking about agronomy, a different way of thinking about plant nutrition. But the good news is we have the tools available today that we don't need to guess about whether our crops have enough. We can start making this transition step by step. We don't have to commit. It's not all or nothing. We can go through the transition at whatever speed we are comfortable with, and we can figure it out as we go along without screwing it up with some of the tools that we have available today. So diving into each of those topics, and within the context of each of these topics, I'm also going to be speaking, because of the context that I'm familiar with, I'm going to be speaking about exactly how we do this in our consulting work at AEA with the growers that we work with. So the first topic, how to effectively transferring nutrition contained in the crop residue to the following crop. Years ago, I originally developed the Rejuvenate as a product to speed up microbial degradation and breakdown of crop residues. And it does so very, very effectively. We've now combined the Rejuvenate with Sea Shield and with Spectrum as a microbial inoculant in a combination that we call our soil primer because of the remarkable effects that combination has. And something to think about is if you're in an environment where you want to keep residue on the soil surface for erosion control, erosion protection from wind erosion and so forth, you may not want to apply the soil primer as a broadcast sprayed on application in the fall. You may want to instead either apply it to the soil underneath the residue or apply it in the spring after the crop is planted, because it makes residue disappear pretty quickly, very effectively. And you get all of the nutrition contained in that residue cycled and converted into bacterial cells and into fungal cells. And this is worth mentioning. This process, when we apply these microbial inoculants and stimulants, this is not like applying nitrogen onto a crop residue. Applying nitrogen to crop residue actually produces a long-term negative effect, because you release carbon dioxide into the atmosphere. You don't build soil organic matter with that process nearly to the same degree as you do with these microbial inoculants. So it's very, very different mechanisms at play. Here's a couple of examples. This was treated on the left, untreated on the right. I have a number of additional photos from this field that I did not include that show the whole landscape view, but the piece I want to point out in these close-ups is look at the center of the corn stalk. On the left, where it was treated, it turns black very quickly. This is about 7 days after application. On the right is the untreated section. And this is pronounced enough that when you look at the whole landscape view, the field on the left actually has a grayish tint to it, and the field on the right has a more whitish appearance to the crop residue. And this residue, 95% disappeared. Even the corn stalks in the ground, the root biomass in the ground was almost completely gone by the following spring. So here's an example of the primer application in cherry orchard. This is applied on top of 4 inches of wood mulch, and there's a few leaves lying on the top. This is incredible fungal development, fungal decomposition. And this is what you want to see happening with your crop residue, because this is really how you build organic matter. You don't build organic matter when you add nitrogen to crop residue. So this is a way of, you could say that this is a way of building your soil's biological nutrient reserves. So when you digest and break down crop residue with soil biology instead of with nitrogen, then you end up having these large reserves of microbially available nutrients, plant available nutrients in the microbial form, going back to the point that William Albrecht made, nutrients that are plant available but not water soluble. So if you have corn residue that corn stover residue that contains, let's say, 60 units of nitrogen per acre, when you use this process, you capture all of those 60 units of nitrogen in a plant available form. So we have this, somehow we've developed this idea that if we want to regenerate soil nutrient availability, we have to use cover crops. But in fact, our crops and our crop residue can serve a very similar function, but most of us fail to tap into that, and our plants don't utilize it very well. In addition to the improvements on residue digestion, as you would expect, when you get this rapid development of soil microbial populations, that also means better soil aggregation, better water infiltration, water percolation, better soil porosity, gas exchange, all the things that we're looking for. This is an example this was a combination of some pretty intensive or extensive, I should say, penetrometer testing done on a farm in Indiana that we worked on back in 2012 or 13 with the soil primer applications. And simply from fall to spring, with a fall application till the following spring at planting, we had these reductions in penetrometer readings across a number of different fields. It was pretty remarkable. This represents about 300 different probe samples. And this is what the corn residue looked like on those fields with the fall versus spring application. They had an accumulation. You could still find 7-year-old corn residue on these fields. Most of it was in the 3 to 5-year-old range or less. And where we put on the fall application, those stalks, the previous year's stalks, we had lots of earthworms inside the stems, and they had largely decomposed on the inside. And the untreated you can see on the left. So pretty remarkable differences. So I wanted to give you a quick example of what a typical protocol would look like for a nutrition management system that we put together, and then I'll go into some further explanations of why we're putting these pieces in place. So I'm going to blow this up and look at each of these in a bit more detail. So we start with what we call our soil primer, and usually that is applied in the fall because we want to have all of that biological nutrient release during the winter months so that we have a nutrient reserve of biological nutrition the following spring. So this is our combination of Rejuvenate, Sea Shield, and Spectrum that usually gets sprayed on. And then the seed treatment of the BioCoat Gold. And then we do a planter application. Actually, I'll go to the next slide here. The planter application is a combination of, and again, I'm talking about AEA products here. They're what we have experience with. This is what we call planter solution, Rejuvenate, Holocal, Rebound Zinc, and Spectrum. Spectrum is the only product in the mix that is an actual microbial inoculant, other than, of course, the seed treatment, the 25 grams of BioCoat Gold that gets applied to the seed. That is a very important microbial inoculant that I'll talk about in just a bit. So I wanted to give you this as an example. This is the nucleus of a biological nutrition program. And you notice what is missing? There's no soluble phosphorus here. There is no soluble potassium here. There's no soluble nitrogen here. And there is a very important reason for why that is the case. We do not want soluble NP, nitrogen and phosphorus for certain. Potassium is usually not effective and doesn't produce an economic crop return when applied at this stage. So when we do have situations where potassium is required, we commonly recommend to apply it later. But there are no soluble nutrients in this mix. When we look at the planter solution contains a very tiny trace amount of phosphorus. It would be measured in a few ounces per acre. And then you have Rebound Zinc, and the Holocal as a calcium product. So that's the nucleus of what a planter application looks like. And we'll modify or adjust that based on specific agronomic context, what's going on with a specific soil or crop combination. And then from that, we'll follow up with a recommendation to take our first sap analysis at V3 stage. And I'm using corn as an example here. I should have mentioned that. I guess it was obvious on one of the slides. And then from that information that we get from that first sap analysis, we'll make a recommendation for an initial foliar application that this is kind of a representative example. And the photomag contains magnesium, sulfur, molybdenum, cobalt, boron, I think. And then we have manganese, zinc, iron, and the sea stem was a liquid seaweed product that has some pretty interesting properties. But again, you notice what is missing here? There's no nitrogen in this recommendation, and no phosphorus, and no potassium. And the simple reason for that is because after using sap analysis since 2011 and collecting thousands of samples, we practically never see low levels of nitrogen at this stage on a corn crop. In fact, our usual nitrogen applications don't begin if in really stressed soils and stress situations. We'll usually begin nitrogen applications after V6. Of course, all of this depends also on the capacity to put on additional applications later. Do we have the capacity to fertigate it on or fly it on or side dress it? And if we do or if we don't, that's obviously going to change our recommendations. We are very conscious of making recommendations that fit a farm's management capabilities and management capacity to produce the highest and the most profitable yields possible. So here's some examples of what root systems look like with and without the soil primer application being applied in the fall. And I'm going to shift gears. I'm going to talk about some of these pieces specifically. Conscious of the clock keeps flying by here. So I want to talk a little bit about the BioCoat Gold and colonizing the root system. There's a few pieces that are really important here. What we've learned over the last 15 years is that If you do not get root system colonized with healthy microbial populations right from the moment of germination, it seems the microbial population never catches up to the plant growth for the rest of the plant's life. So that first 2-week window, those first 10 to 14 days during the germination process, we want to get that root system completely colonized with biology. That gives us so many benefits. One of those benefits is disease suppression. So when we are able to get effective colonization, complete colonization of that root system, you just do not see problems with Fusarium and Rhizoctonia and Pythium and all these soil-borne pathogens, Phytophthora, just do not become a problem, neither in those first couple of weeks of plant life, but also later on through the rest of the plant's life. Because what happens is the soil, the colonization, the soil microbiome, and the plant need to somewhat grow in parallel with each other. We know the plant feeds the biology feeds the plant. There's this symbiotic relationship going on. But what happens is, if you don't get colonization in this first 2-week window, the seedling will grow up to be a couple of inches tall, and the root system will start to grow very quickly. And then, depending on what is happening with fertilizer applications and so forth, at some point, biology will begin to colonize the root system several weeks in. But at this point, the root biomass already has dozens or maybe even hundreds of longitudinal inches of root biomass. And the microbial community never catches up. It never completely colonizes that root system, and it doesn't colonize it effectively for the rest of the growing season. It never really catches up. Well, this is really important because that means it creates that creates a situation where that root system is now dependent on applied fertilizers. If you do not have complete microbial colonization in the first 2 weeks, for the rest of that plant's life, it is always dependent on soluble ions. So it requires nitrate ions and potassium ions and phosphorus and calcium ions from the soil solution, because this biological nutrient delivery mechanism and process that I've been talking about never functions entirely. It's never able to deliver 100% of what the crop needs. Oh, and by the way, the very best way to shut down this colonization process in the first 10 to 14 days and prevent it from taking place effectively is to apply soluble nitrogen and phosphorus in the furrow. You apply 10-34-0 or a similar product that contains soluble N and P at a rate of a couple gallons per acre in close contact with the seed, you will not get this type of colonization. It's not going to happen, because many of these, well, there's a number of mechanisms, but let's just say in brief that that flush of highly soluble, highly available nutrients gives the plant the signal that it lives in a nutrient-rich environment, and it doesn't need to feed the biology. So it never transmits out the sugars that the biology need to form effective colonies on the rhizosphere, on the root surface, and therefore colonization never happens. And flash forward 2 weeks, a small amount of nutrients applied in the furrow or on the seed at planting has now either become complex in the soil profile, or the plants have used very tiny amounts of it. And now the plant no longer lives in a nutrient-rich environment, but the crop is hooked. You've created a drug addict for the rest of that plant's life. It is now dependent on soluble fertilizer for the rest of its life cycle. And this is one of the really big pieces that we've made significant changes and shifts in, is when we are dealing with soils that are really struggling, that are really challenged, that don't have lots of biological activity and do not deliver nutrients very well, if we are in a situation where the soil still needs and the crop still needs the application of soluble nitrogen and phosphorus fertilizers, which is not that uncommon, we distance it out from the seed. We'll put it in a 2x2. We'll put it somewhere away. It's not right by the seed, because the first 2 weeks we want colonization to happen. And then 2 weeks down the road, when that root system reaches out and reaches that nutrient-rich zone, we already have microbial colonization happening. And then the second piece is that if we do need to put these soluble nutrients in the 2x2, we are cautious to not over apply. We only apply what the crop is going to require in the first 6 to 8 weeks of plant life, not for the entire growing season. And the combination of those two things has produced dramatically different crop responses and crop results, where we're able to produce really high yields without the these constant high levels of nitrogen and phosphorus and nutrient inputs. There's one other piece I want to point out. These colonized root systems are not nice and white. If you sometimes see product promotions where they're promoting seaweed products or different types of products where they pull plants out of the soil and they have these beautiful white root systems. That's a problem. White root systems exposed, unless they've been washed off, should not be the case. What we want to see is we want to see this very active colonization and aggregation happening around the rhizosphere. So this is an example of an AEA program, and this is winter wheat. There was a combination of different seed treatments applied to this seed before it was planted. It was BioCoat Gold, Rejuvenate, C-Stem, and some other trace minerals. I forget what the entire combination was. So it was a combination of products applied to the seed before the seed was planted, and this is 1 week after planting. This is the type of root colonization that we're looking for, not just root structure. Root structure is interesting, and the root biomass is interesting relative to the plant biomass. But what is really valuable and important here is just the soil aggregation that's sticking to the root system as an indicator of microbial activity. All right, so in conclusion, the one product that is a must-have here is BioCoat Gold as a seed treatment. And BioCoat Gold gets used so widely, and it has really kind of established a reputation on its own. I hardly need to promote it or talk about it. But BioCoat Gold was developed using this concept of what we call synergistic stacks. So it's not just mycorrhizal fungi. It's not just materials that stimulate fungi and bacteria. It's not just nutrients like calcium. It's not just bacterial inoculants. It is all of those things in combination. And yes, I know all of those things in combination don't show up on the label, and that's because regulators create headaches for themselves and creating conflicting rules that you can't possibly comply with all of them at the same time. So you have to pick and choose. So there is, the short version is, BioCoat Gold has been put up against lots of seed treatments over the years, and for some reason, growers keep using this one at the end of those trials, and it gets used on millions of acres today. There's a common question that we get about BioCoat Gold. Can it be used when seed has already been treated with fungicides? The answer is yes, it can. It still produces a crop response. I don't pretend to know how that works because obviously mycorrhizal fungi, I would imagine, doesn't do particularly well in the presence of fungal seed treatments, but perhaps that's because BioCoat Gold is much more than just mycorrhizal fungi. There's a lot of other goodies that are at work there as well. So it gets used mostly on treated seed rather than untreated seed, simply because that's what most people have available. And here's further examples. Now, these are examples of actual washed root systems that still don't have that pearly white root system showing up because of soil aggregation. The next piece I want to speak about, just address this quickly and briefly, is you want all of the nitrogen that you apply. If there is a need to apply UAN 32, liquid urea, whatever form of nitrogen that fits your system and that you have available that is being applied, other than anhydrous ammonia, I think that doesn't really fit in these biological systems for reasons we can get into if you're interested. But we want any form of applied nitrogen to be rapidly consumed by soil bacteria and stored inside bacterial cells. Why? Because those bacterial cells are available nutrition for plants to absorb, but they are not water soluble. They don't leach. They don't disappear when the water disappears. So if you have drought conditions, you can still get biological nitrogen into the plant, unlike with nitrates and ammonium. So the question is, how do you do that? How do you make that happen? I have an entire webinar on YouTube where I talk about nitrogen efficiency management that you can get into the details and the rationale behind this. But here's the summary conclusion of the nutritional protocols that we use today. We add humicarb at 3% of the total nitrogen solution, rejuvenate at 3% of the total solution, and rebound molybdenum at a pint per acre, and sulfur, usually in the form of ammonium thiosulfate, in high enough amounts to achieve a 10-to-1 nitrogen sulfur ratio in the mix. When you apply this combination, you don't need AEA, you don't need consulting. The reality is you don't even need SAP analysis. You can put this combination into a liquid nitrogen solution and cut your nitrogen application rates by 30 to 40% over what is common in an area and still produce the exact same type of crop response. In fact, you're likely to produce a bigger crop response. The short version, I'll refer you to the webinar that we've already done, have out there if you want to dig deeper into this. But what is essentially happening here is this combination is designed specifically so that when a liquid nitrogen solution is applied to the soil bacterial population, it's what you call a bacterial bloom. This bacterial population just explodes and immediately consumes all the nitrogen. And when I say immediately, I'm talking dependent on soil moisture and soil temperatures, but if you have good moisture availability, you should have all of the applied nitrogen be internalized into bacterial cells in a matter of 3 to 5 days or less. And this is really valuable and really powerful because that means your nitrogen supply is not going to leach. It's going to be available for the plants no matter whether you have drought conditions or whether you have excessive moisture conditions. That nitrogen is going to stay right there. And that's why you can reduce your nitrogen applications by 30 to 40% without having a reduction in crop response. I'm going to move on past the soil primer. So the last piece I want to mention, this has been such an important piece for us. As we've worked with many different growers in different contexts to help make this transition and develop these biological nutrition management systems, we all know that every soil and every ecoregion is in a different place. You have different climate factors, different degrees of rainfall, soil temperature, moisture levels, different levels of soil organic matter, historical toxin exposure in the forms of pesticides and fungicides that change the soil microbiome. The short version is that every situation is unique. So when you recognize that and acknowledge it, how do you manage these biological nutrition systems without screwing it up? How do you make sure that you don't cost yield and that you don't cost a crop? Because you all know it's today there's lots of requests for further research and for more information on the effects of microbial inoculants. Like we have all these inoculants now that are on the market that, we can fix 40 units of nitrogen per acre, we can fix this many units of nitrogen per acre, we can reduce your nitrogen applications. And there's lots of growers calling for research, further research. Okay, where's the data to support this and how does it work in different fields and different environments? Well, we know from all the experience that we've had that those types of products, your mileage is going to vary significantly just by the very function of their biological nature. As you know, if you were to plant one bean variety or a corn variety or any given crop variety into very different contexts and conditions and soil conditions, you're going to get very different results. The same is 10 times more true of biology than it is of plants. And so the bottom line is, how do you verify and how do you know that a product is being effective or not? And how do you make that determination early enough in the crop's growth cycle so that you don't cause problems and that you don't learn that the product didn't work at harvest time? That's not when you want to figure it out. You want to figure it out before then. And so our tool for gaining clarity and insights into what is effective and what is not is plant sap analysis. I must have 100, well, maybe not 100, but probably dozens of webinars on YouTube and various places about our work with plant sap analysis at this point. The And so I would refer you to those if you want to dig deeper. But the short version is that we pick a couple of reference fields. You don't have to do it on every field across the entire operation. Pick a couple of reference fields that have soil types, if possible, similar to what's on the rest of your operation, and measure those reference fields consistently throughout the entire growing season, every 2 weeks or every 3 weeks throughout the entire growing season, just like clockwork. And there's lots of things that happen with this. One is you can very clearly observe which products worked and which didn't. And this is one of the reasons why more input companies don't use SAP analysis, is because they quickly discovered that products they were recommending were not being effective or were not necessary. And I think that's a bit of an indictment of their integrity, but that's a separate conversation. But then what happens is also year over year, you get to see these nutrient trends at different stages of plant development. You get to see what's happening and what's going on inside the crop. And this is really valuable. So we use SAP analysis early on in the plant's life to determine whether, in a case of a corn crop, whether we need to add additional nitrogen later, and if so, how much. And this gives you a tremendous amount of confidence, because all of a sudden you don't need to stand there looking at your field and being worried to say, I only applied 20 units of nitrogen at planting instead of my typical 80. And I'm really concerned about what that crop is going to look like. And I think I need to go out there and apply more nitrogen. With a SAP analysis, you don't have to worry. You don't have to guess. You can get the data and you know precisely where you are. And you can see precisely where the crop is going to go in the future. And that is just so valuable and so powerful. So as I described, you can track crop responses to different product applications. And you can also compare different types of management systems, compare different varieties and compare different fields. And you start seeing really interesting trends in the data show up when you do these comparative analysis throughout the growing season. So in conclusion, as you've probably been able to figure out from other presentations, if you've listened to me or to David Miller or others on our team in the past, we're very passionate about what we do. We have a lot of fun. We have a lot of fun working with our growers. And it's true for all of us in life. You didn't come here to this presentation to see how you can benefit me, or you came here for yourself. And all of you want to work with people who share your values and who care about the things you care about. And the same is true for us. We also want to work with people who care about the same things that we care about and who share our values. We want to make a difference in the world. We want to help growers, and we want to work with you to make a difference in your operation if that's what your goals are, if that's what you want to do. So if that's the case for you, we invite you to, I want to invite you to reach out to us. If you're serious about experimenting with or developing a biology-centric nutrition management system for your operation, we know spring is here. It's coming fast. It's already happening. Planting is already happening in certain parts of the country. And we'd love to work with you to help you figure out what does a transition look like and how do you get started down this pathway based on data and not based on guesswork. So please call us, call our team. We're happy to talk to you. So with that, I'm going to stop the screen share. I'm going to slide into the Q&A. That 48 minutes went by really fast, really quickly. All right, so let me see how I can navigate through this. First question here is from Mr. Anonymous. Interesting title here. In other presentations, you've mentioned the importance of the proper oxidation state of mineral nutrients for effective utilization by the plant. Do specific chelating agents influence the oxidation state? The answer is no, or at least not as I understand it. Perhaps indirectly, but let me say it this way. Influencing the oxidation state and influencing chelation are two separate different things. There are materials that can do both, but it's not necessarily true that they do both, as I understand it. Can you recommend resources to learn about the desired oxidation states for various nutrients and how to attain those states? Yes. The first, as a background reference material to really understand this topic, I would suggest you go to kindharvest.ag. Sign up. You can sign up for a free month there, although there's a subscription to be there for longer than a month. And take Olivier Houssan's free course. He has a course there that's 6 hours long that is incredible. and will completely change the way you think about agronomy and plant nutrition. So that's an excellent reference background material. And then for the rest, Google, Wikipedia, and there's quite a number of different sources out there on the different oxidation states. It's essentially, you have to look at the biochemistry and really get into the biochemistry of what's going on. Question here from Russ. If cornstalk residue is sprayed with soil primer, what effect does this have on a grazing animal? It'll have the effect that it's going to make the crop residue a lot more digestible. You're going to get more nutrients out of it for the ruminants. I mean, it's essentially the same thing that's what's happening with soil biology. You could almost consider it a pre-digestion for the rumen, which is exactly what's happening in the soil. It is a pre-digestion for the crop's microbiome for the coming crop. So it's going to increase your energy that the livestock are absorbing from the forages. In fact, there's a number of beef and dairy operators who use this product for precisely this purpose, because they get some really nice animal responses from putting it on crop residue or even feeding it directly. Question from Paul. Long term, will your program pull down the soil test results significantly? Well, depends on how you define long term, Paul. We're now in it 15 years, and there's two parts to this answer. One is that we, on greater than 90% of soils, we see phosphorus and potassium levels continue to increase with this program, not to decrease, but to increase on a soil analysis report. Trace mineral levels, your mileage is going to vary. And over the last couple of years, we've started widely using what we call a total digestion analysis. There's many labs that run this total digestion assay. You can ask Midwest Labs or Ward Labs or Regen Ag Labs or Logan Labs, are the 4 labs that we see the most data coming through from, although there's many others. All 4 of those labs I know for certain run this total digestion assay, and it measures the total nutrient reserves that are in your soil profile, let's say in the top 6 inches, if that's what you're measuring. And it's important to know this data when you take this biological approach to plant nutrition, because there are some soil nutrients which you have enough soil reserves to last centuries. I mean, some soils will have 2,000 pounds of manganese and 40,000 pounds of potassium, but other soils don't. Other soils will only have 200 pounds of potassium and 20 pounds of manganese. And so on those soils which don't have large reserves, I'm not suggesting or not advocating that this is biology alone without the absence of applied nutrients. In some soils, you can greatly reduce or eliminate the application of applied nutrients, but not in all soils. And so I think that's maybe a bit of an indirect answer to your question of what you're asking. The short version is, when you have soils that have abundant, let's say they have abundant potassium and manganese in the reserve soil profile, we see those levels go up over time. But if you have a really sandy soil that doesn't have those reserves, it's absolutely possible to see soil depletion. And we take our approach based on sound agronomy, not hyperbole or wishful thinking. So I do not have an idealistic perspective to say you should never apply potassium or should never apply phosphorus. If your soil reserves are not there and your biology can't release it, you absolutely need to apply some to produce high yielding crops. Question here from Adam. I know BioCoat Gold is probably mainly geared towards commodity crop, but would it be useful to use in diversified vegetable operation, in germination and microbial colonization of tomatoes, peppers, etc.? Adam, the short answer is yes. BioCoat Gold has enough diversity of just the mycorrhizal species alone will colonize and form symbiotic relationships with over 200 of our primary crop species here in North America. And the bacterial population is even broader than that. So yes, we use it on fruits and vegetables, and use it on fruit trees, brambleberries. It's kind of across the board. There's a very few outliers, like blueberries have some specific ericoid mycorrhizal fungi, but for the most part, this is really relevant. And when you're working with us in a consulting relationship, or when we work with you, we make very clear recommendations for when BioCoat Gold is not the right fit as well. Next question from Mr. Anonymous. You're talking about a starter fertilizer at a 2x2 placement for colonization. Would you define the same scenario with a pop-up fertilizer that is applied in the furrow? So in the case of a pop-up, I like pop-up applications, but in the case of a pop-up, I would use a biology-centric pop-up that doesn't include the soluble nitrogen and phosphorus. I would simply put the nitrogen and phosphorus somewhere else off to the side and use like an example of that starter that I described, the starter solution. You're looking at a total solution of a couple gallons per acre that is going to really stimulate biology in those first couple of weeks right after germination, and that's what I would put in the pop-up. I think if I'm understanding your question correctly, that's the right answer. A question from Matt: how did you pull this seedling root out of the ground? I'm not sure which picture that was in reference to. I think the taller wheat seedlings that were 6 to 8 inches tall, a shovel was obviously used for those, but for the smaller stuff, our rule of thumb is to just pull it straight out, or maybe loosen the soil first with a shovel, but I wasn't there when that picture was taken. I don't know the answer. Hi, Tim. I answered your most transformative AEA product question. You'll try to think of another. All right, that's good. Only challenge is we have about half a dozen of most transformative products, so there's a lot going on out there. Question from Matt: can you apply BioCoat Gold to the seed hop wrap planting? The answer is yes. It happens all the time. Lots of growers apply it like that, and as well as applying it in advance. Question from John: I've contracted a strip tiller to apply 100 pounds of P&K with 120 pounds of NH3 each year during late November, early December. Oh dear. Then I side dress another 80 pounds of N via wide drop during the VT stage. Do you have a recommendation for adding your products to my current practice? Goodness, John, this is an interesting question, and perhaps a conversation. There's more details that we need to know before I'd be comfortable making a specific recommendation. But one of the fundamentals when we think about developing a biology-centric nutritional protocols, one way of thinking about that is to say that we should be managing our topsoils as if though it were a petri dish. We want to cultivate as much biology in our topsoil environment as possible. And this is one of the reasons why when folks talk about the 5 principles of soil health, they describe keeping the soil armored and keeping it covered. And one of the reasons for that is to protect it from the sunlight, because as you can imagine, when bare soil is exposed to the sun, heats up. I've seen bare soil get up to 140 degrees Fahrenheit on the soil surface and 110 degrees down 2 inches deep. And you can imagine biology doesn't thrive in that environment. In fact, all the enzymes are denatured above 110 degrees Fahrenheit. And so similarly to some of the practices that you describe, and I'm describing this not as an indictment or as a negative in any way, but just for the benefit of everyone here in the audience. Many times, one of the key pieces to this pathway to start moving forward is to discontinue doing the things that produce damage, that produce harm to soil biology. And the anhydrous ammonia definitely fits into that category in a major way. So we need to figure out either how to change out the anhydrous with a nitrogen application in a different form at a different time, or how to buffer that out. So that could be an interesting conversation in and of itself. That's kind of the step one that I would suggest is let's figure out how to, first of all, do no harm, the first rule of medicine. That's essentially the approach that we need to take here. But then in addition to that, so leaving that as an aside, in addition to that, the other piece that you mentioned is the 80 pounds of N at a wide drop during the VT stage. That would be a perfect opportunity to add the nitrogen remediation or the nitrogen stabilization, nitrogen efficiency program that I talked about, adding in the humicarb and the rejuvenate, the molybdenum and the sulfur. You're going to get a lot more efficiency out of that late stage nitrogen application. And you have that timed really well already to begin with. And then the other recommendations that I would have would be the seed treatment and the planting in furrow. You haven't described what you're doing there, but I would suggest taking a look at those as well. So I hope that those answers your question, and I didn't intend to offer my comments in any negative sense to as an indictment, but simply want to describe for everyone's benefit some of the challenges that some of these products have and how we need to begin thinking differently about them in the future. Question from Michael: how do we deal with abiotic conditions that affect microbial activity? In the north, for example, cold springs seems to suppress microbial nutrient cycling. Michael, the short answer is yes. In reality, you can have soils when I would say soil saturation is a bigger challenge than soil temperature. As long as you have soils that have what is called microbially active carbon, in other words, the fraction of organic matter and soluble sugars that biology can access, they will continue nutrient cycling even when soil is frozen solid. It slows down a lot, absolutely, but it still happens. It never completely stops. And that's not the case in saturated soils. So I actually have a lot more concerns about wet soils than I do about soils that are cold. Now, with that being said, there is a kind of a cumulative effect to soil biology. Many growers who've been using cover crops and developed biological nutrition management systems over a couple of years report that their soil warms up a lot faster in the spring. And I'm sure some of you have probably seen the photos where you have photos of snow out over multiple fields or across the plains, and then you have a few fields that just pop out because the snow has all melted off. And that's a function of microbial activity. So over time, this is not something that I would predict or expect to see in the first year or two, but over a couple of years, you're going to see soils with good biological activity will warm up faster in the spring. It's definitely something that we have observed. Question from Lisa: can you please explain how fertilizer salts impact soil microbes? I heard recently that it desiccates the microbes and that salt fertilizer products are more damaging than that solid fertilizer products are more damaging than liquid products. Yeah, Lisa, this is an interesting question. You can easily look up the salt index of different fertilizers as contrasted to sodium chloride. I think potassium chloride is something like 116 on a scale of 0 to where sodium chloride is 100. Potassium chloride, I think, is 116. Ammonium, anhydrous ammonia is also pretty high up there. And the correct terminology is that it oxidizes cell membranes. So when you have a cut on your finger and you get a salt fertilizer or liquid fertilizer into it and it burns, that burning is oxidation of the cellular membrane of your tissues. The same thing happens to soil biology. When you have high concentrations of salts, it will burn the cell membranes or essentially you could say oxidize the cell membranes and have the effect of shutting down soil biology directly by that mechanism when it's present in high concentrations. But even when it's present in lower concentrations, let's say you have, to the earlier question, if you apply 100 pounds, or let's say you apply 100 pounds of nitrogen in the fall in a strip-till zone, there's one question to ask, which is how much of that is still going to be present in that zone the following spring versus how much of it has leached out. But let's, for the sake of discussion, say that the majority of that is still present in that zone the following spring. So now you have a nutrient-rich environment, a nutrient-rich zone, a nitrogen-rich zone. And in that zone, the corn seedling will recognize, or any plant seedling will recognize, that it has abundant levels of nitrogen and it does not need to feed biology to get nitrogen for it. And so it doesn't. And so even having a zone where you have an abundance, you could say a surplus of soluble nutrients, will have the effect of shutting down colonization because the plants won't expend energy to support the biology to go out and get that for them. Question from Michael Snow: what can monitoring plant sap pH tell us? Michael, Bruce Tainio wrote quite a bit about this back in the late 1980s, and I published some of his information on the blog. So go to johnkempf.com or just do a Google search for John Kempf and sap pH. I think it'll come right up to the top. I'm being conscious of time here. The short answer is, according to Bruce's research, it can show us disease and insect susceptibility. But I think there's more. We now know more than we did in the late 80s, and there's a bit more to that story. We have to measure not just pH, but also EH, or redox, in the plant tissue. But you can go look at that. And I would also suggest looking at Olivier Houssan's work. He looks at the combination of pH and EH, and in describing disease and insect susceptibility with a high degree of accuracy. Question from Peter: do the temperature and relative humidity have an effect on the product? Majority of our products are liquid. In the case of BioCoat Gold, it's a dry powder and it's a living inoculant. So if you expose it to the atmosphere and you get a lot of humidity in it, and it's going to start coming alive. So not a great plan. Question from Alex: do you feel tissue samples offer a similar reading to plant sap analysis? No, absolutely not, by multiple orders of magnitude. I spoke last week at a wine grape growers event in Napa, California, and one of our growers that we've worked with for several years presented on the results, what they've learned with plant sap analysis. And his analogy of plant sap analysis was, he said, dry matter tissue analysis is like driving a horse that isn't properly shod and has a lame foot, versus plant sap analysis is like matter transfer with the Star Trek Enterprise. And I kind of laughed about that analogy, but it's absolutely true. The short answer is there's no comparison. From an agronomic management perspective, it simply doesn't compare. I've done a number of webinars on YouTube on this topic you can dig into more deeply if interested, but the short version is that it shows nutrient deficiencies. It is so much more sensitive and accurate and earlier. Depending on the speed of plant growth, it will show nutrient deficiencies 3 to 4 weeks earlier than a dry matter-based tissue analysis. And that's a really big deal. Do we have experience in Latin America? We're starting to do some work in Brazil, and we've worked in Chile and Peru in the past on berry crops. Where do you send off samples for sap analysis? Here in the States, we use Crop Health Labs, Nova Crop Control in the Netherlands, and those are the primary. There's other competing sap analysis labs out there, but let's just say that Nova Crop Control in the Netherlands developed the technology first 20 years ago, and as at this point, everyone else is still trying to catch up to their proprietary technology for getting consistent, reliable results. Question from Alex: what are some books or research material that you recommend to better understand these processes? So Alex, kind of the nexus point where I bring together as much of this information as I can in one place is my website, johnkempf.com. We have a YouTube channel. I host the Regenerative Agriculture podcast. I write a blog, and all of that is kind of linked together in one place there. Try to bring that all together. And the good news is, this is the nexus of our consulting work at Advancing Eco-Agriculture. We now have a team of over 70 people that do just this all day long, full time. And our team is growing quickly. So we have a lot of resources on our staff. Feel free to reach out to us, call us, and we're happy to guide you through the process of what works for you. Alex, to dig into this a bit more deeply, I actually have one blog post that is just titled My Recommended Reading List, specifically for books. And there's a lot of references there to specific topics that you might be interested in diving into more deeply. Question from Drew: can you give a brief overview of strategies on sand or very low organic matter, very low CEC? Drew, I'm conscious of time. Trying to think of how I can answer your question simply, but I would say that broadly, generally, first of all, biological activity is not dependent on total organic matter. It's dependent on microbially active carbon. So you can have low organic matter soils that still have abundant microbial activity. So that's a very key piece. The second is, on these sandy soils, obviously you do not have lots of nutrient reserves. And so you need to support the soil nutrient reserves and support the crop's nutritional requirements with applied fertilizers or soil amendments on an as-needed basis. So that's kind of really broad description. And then you also have a follow-up question on fall applications for residue management. Compare benefits when the soil is snow covered over winter versus no snow and extreme cold. The benefits are going to vary based on what it is that you're looking for. You're looking for wind erosion control, or moisture penetration and so forth. The residue breakdown is going to happen. It's even going to continue when the residue is frozen solid and when the soil is frozen solid. It never stops entirely, although it does slow down. And we see it working very well in both of those environments. I mean, at this point, it gets used all the way from Texas to the Canadian plains. Question from Lisa: can spectrum be added to a static compost pile to speed up the decomposition and shorten the composting time period? The answer is yes, it can. You might also want to look at an inoculant called biodigester, also from Tineo, but both of those will speed up the decomposition. Question from Lloyd: can you combine soil primer and nitrogen efficiency, and is there a benefit to that approach? Well, Lloyd, I would say you want to separate your soil primer from a nitrogen application, because you want the soil primer to establish robust bacterial populations that sequester and fix nitrogen in the absence of legumes. And those don't establish populations nearly as well when they're combined with a nitrogen application. So I would suggest separating the nitrogen application from the soil primer application. Question from Ben: how would it work on range pastures? Same concepts, same principles, except even better. Better because pasture grasses have very robust root systems that are even more capable of extracting and getting biologically delivered nutrition than some of our modern cultivars of corn and wheat and beans, etc. Question from Tom: is there a concern with blowing and vacuuming BioCoat Gold seed treatment with air seeders and planters? Do we need to use a sticking agent? Tom, that's probably a question a few of the consultants on our team are more qualified to answer than I am. I know that Ted Bruns and Kip Harvey have done some extensive experimentation with this, and I would refer you to them. I know that it gets used a lot with vacuum planters. The primary issue with it, as I understand it, from a product performance perspective, is making sure that we don't get too much shear pressure and nozzle shear. But I don't see that being a major concern. But Ted Bruns or Kip Harvey on the AEA team are two agronomists that would both be better qualified to answer that question than I. Question from Steve Snyder: in discussion about root colonization in early plant development, discuss how a manure application would affect this process. Would the nutrients in manure also inhibit development? Steve, the short answer is probably yes. So if you have soluble nitrogen and soluble phosphorus being applied in the manure, that will have the same inhibition effect as soluble nitrogen or phosphorus from an applied fertilizer. That can be buffered out to some degree. I have a blog post where I talk about how to turn liquid manure into liquid gold. The short answer is it's actually not that difficult or that expensive to turn liquid manure into the equivalent of a liquid compost tea brew. Like you can, with a very small amount of microbial inoculants and stimulants, you can turn a liquid manure pit into this very clean, when I say clean, it's a non-smelling and non-odorous product that is a pure liquid and has digested and broken down all the solids in it. It's actually pretty impressive what can happen. And when you have that level of microbial activity happening in the liquid manure, then the nitrogen that's in it is going to be contained inside the bacterial cells again. And so when you have this really healthy liquid manure, almost as a compost tea, if you will, then that does not have negative effects on the soil biology and this early colonization. Question from John: how far in advance can BioCoat Gold be applied to the seed? As long as it's kept dry, I don't know if I can accurately say indefinitely, but it's a common practice for many growers to apply it during the winter months and not seed until 3 to 4 months later, and still get the same effects and responses that we're expecting. Question from Ross. In your experience, how does a crop program evolve over time? Is there a weaning process for certain products or a need for different processes? Possibly not a need for any. Ross, that's a good question, but it's a question that could take an entire hour to answer just because of all the different contexts. It's the context of what are the farm's goals? What is the soil context, the geological context? What is the crop mix, the crop rotation? So if we're working on strawberries in California, where they're going to do strawberry plastic culture year after year after year without a cover crop and with fumigation, then there's probably some things you're never going to get away from. But in different cropping systems, cropping contexts, it is absolutely possible in some contexts and in some soil types to greatly diminish or reduce the use of nutritional inputs and AEA inputs. I mean, we have customers now who are now former customers because they no longer need us. They no longer need the products we've applied, and they no longer need mainstream inputs as well. So I keep being reminded by some of our advisors that that's a very interesting business model to work ourselves out of a customer relationship, but that's the pathway that we're on with quite a number of growers, and I find that quite exciting because there's lots more acres that need help. Question from Kevin. Do you have side-by-side yield results with planter treatment? Yes, we have many farms. In fact, when we work with a farm, we want to get side-by-side experience on your specific soils, but the results from all the other farms we've worked on are not going to not necessarily transfer directly to yours. So do your own trials and expect to see something different from the folks 50 miles down the road. And all of you already know that. It's kind of Captain Obvious, but the short answer is, with this biological type nutrition management approach and with our use of sap analysis, we've been very privileged and very fortunate. We have a pretty impressive track record of producing some very nice yield responses while also reducing inputs at the exact same time as we're getting the crop yield responses. And again, you can go to our YouTube channel for quite a number of case studies of that happening. But you're going to have to figure out what is going on for your operation, and it's going to be different from guys who have a different management system. Question from Leland. Will a healthy biological soil continue to need bio inputs in the presence of diverse cover crops and rotations, as well as other bio-friendly farming practices? So, Leland, I partially answered this question earlier, but let's take this when you say bio inputs, I'll assume you're referring to microbial inoculants. If a soil needs continued applications of a microbial inoculant over extensive periods of time, I would suggest that means either that A, the inoculant is not effective at establishing a viable long-term population, or something is being done in the management practice context that is damaging that population once it's been established. Both of those could be a possibility. And then regarding this nutritional protocol, as I described, it's entirely possible for us in some crop contexts to work ourselves out of a job. And that's our goal. Question from Neil, is BioCoat Gold available in the UK? That's a question you'd have to ask the AEA team. I am under the impression that if it isn't yet, it's in the regulatory pipeline, or expected to be in the regulatory pipeline to get that approved over there at some point in the near future. Follow-up question from Alex. What's the best way to extract plant sap, and what is your opinion on refractometers? Alex, I have some fairly thorough and in-depth blog posts on plant Brix readings and refractometers on the blog. So in the interest of everyone's time, I'll just refer you to those posts. We have, I've already put a lot of information out there on these topics. Question from Steve, can cattle graze corn safely when treated with your products? The answer is yes. I think this was also the first or second question that I answered. Not only is it safe, but you're going to actually see improved energy from the forages, maybe you could say improved feed conversion efficiency, particularly on crop residue as compared to green plants. So you're going to see you should expect to see some results there. Do you have any recommendations for products? This is a question from Laurent. For products to apply to compost to increase fungal composition, what tests do you recommend for compost? Laurent, that's outside my area of expertise. I've seen a bunch of interesting stuff with Johnson Sioux and with vermicompost. I actually think vermicompost is an underrated and underappreciated input. But the only comment that I'll add for the fungal populations is we've seen some really interesting fungal development on soils where either a high oil content liquid fish was applied to a crop residue as it was breaking down, or when we had crops that naturally had a high oil content. So that would be something to look at. I tend to think of fungal populations being associated with high fat content plants. Question from Martin. Is it advantageous to use the soil primer product in a pasture? The short answer is yes. And of course, the degree of response is going to depend on the relative state of health of your pasture initially, but you should expect to see a nice crop response. Question from Tim. 2 more questions and I'll wrap up here. Would you agree that the rhizosheath or rhizosphere soil of a living or senescing plant is the ideal habitat for all or most germinating seeds? That's an interesting question. At least as compared to the habitat provided by bulk soil where no living root has been present for, say, at least 1 month. That's an interesting question, Tim. I don't know, I haven't thought about it in advance, but my initial reaction would be it may depend on the plant species. So some plant species are, they tend to germinate during the dormant season or when there's not a lot going on. So there may not be an actively living or photosynthesizing root in immediate proximity. And something else to think about is that according to Dr. White's research, when you have really healthy plants with functional microbiomes, that is transferred to the seed coat. So it's transferred from mother to daughter. And so you should have the beneficial biology on the seed coat. And that would be one way of affecting or transferring microbial activity and not just through the soil profile. And then the last question, in one of the 2 free courses at Kind Harvest, your presenter spoke of a kind of magic that happens between mycorrhizal fungi and short-lived perennials as the perennials senesce. Could you speak a little as to why senescent perennials cultivate mycorrhizal fungi better than annuals and long-lived perennials, not including C4 grasses, perhaps? No, I don't know the answer to that question. And I would suggest you direct that to whoever made that. I think that might have been perhaps Nicole Masters or perhaps Harriet Mella. There are some interesting things going on. I think Christine Jones talks about this in some of her research as well. But if you want to have us follow up with that question, please send me an email and I'll try to dig a bit more deep into that and get you that information. So that concludes the questions. I want to say thank you for all of you for being here. I hope you found the information valuable and useful. And we'd love to work with you. Please reach out to our team, call us. We can't call you because we don't know who you are and your contact information, but call us and we'd love to work with you and figure it out. Thanks, everyone. Have an awesome day.
Yep. Thanks, everyone. And thanks to John for sticking around to answer all those questions. As a reminder, today's presentation and audio will be available on the No-Till Farmer website. So if you'd like to review it or share it with anyone you'd like, you'll also receive an email within 48 hours of the recorded presentation. On behalf of Advancing Eco Agriculture and No-Till Farmer, thank you for joining us for today's digital demo. Please feel free to reach out to let us know what you thought of the live event and if there are any other topics that you'd like to see us cover in future webinars. Other than that, thanks everyone, and please enjoy the rest of your day.